Good morning, good afternoon, everybody, wherever you're dialing in from. As Andrew said, my name's Donald Tebow, and I'm the Director of Product Management here on the Hedera team. So Zin and I are really excited to talk with you today about some of the work we've been doing to support the use of the Hedera Consensus Service with one of the leading permission network frameworks called Hyperledger Fabric. So we'll show you today a bit of the basics about the Consensus Service, the plugin we've built for Hyperledger Fabric, and how you can get up and running with that plugin yourself using the IBM Blockchain Platform to manage your Fabric network. All of the code and samples you'll see us walk through are available in our GitHub, and we're really excited to show you how to get up and running yourself. Now, to give a bit of background, today often developers who are seeking to build business solutions or consumer applications are forced to choose between one of two models, either a private network, which gives them the ability to configure and manage privacy to govern the participants of the network, but comes often at the expense of centralization. It's often deployed in a more localized environment. It can struggle potentially to scale as the network needs to open up to new members and can come at the expense of vendor lock-in. Conversely, the other alternative is to build on a fully public network, something like Ethereum or Bitcoin. In doing so, you might get potential decentralization. Although the networks are operated by anonymous node miners, they're generally spread across the globe. But it comes at the expense of performance. The scale needed for enterprise and consumer applications is thousands of transactions per second versus tens. There's inability to enforce privacy, and there's some loss of anonymity, and can potentially be a host of regulatory concerns. So one of our objectives with the Hedera Consensus Service is to provide a simple set of APIs that can be used by any permission network builder to get a consensus order of transactions from the Hedera public network. So rather than needing to stand up and manage your own set of ordering nodes to support consensus within Hyperledger Fabric or R3's Corda, you can use the Hedera Consensus Service essentially as a service for ordering transactions, given that it's deployed on the globally distributed Hedera mainnet operated by the council members. In using this pluggable model for consensus, you really get to combine the best of both worlds. Tools like Fabric are incredibly helpful in providing privacy customization in terms of chain code to a specific business use case, the ability to encrypt and control data, and the ability to onboard and manage participants in the network. These are the types of tools that the framework is most powerful in providing. By using the Hedera Consensus Service in that Fabric toolkit, you can get the trust of a decentralized transaction orderer provided by the Hedera Consensus Service. It's highly available in that the network is always on, operated across the globe. You get finality on the order of transactions in a matter of seconds, and you get the performance needed for many enterprise and consumer scale use cases. Today, the Consensus Service is throttled to 1,000 transactions per second on the mainnet, and we're eager to continue increasing that over time. Now, I want to tell you just a little bit of a refresher on the Hedera Consensus Service before we get into the plugin itself. At the core here, we have our Hedera mainnet nodes. These are the nodes operated by council members, distributed across different on-premise and cloud environments. They use the hashgraph consensus algorithm to determine the consensus timestamp of a message. It's the unique down to the nanosecond message timestamp of when that message came to consensus. Now, what's unique to hashgraph is these nodes have what we call a short memory. They're using hashgraph to determine the timestamp of events, but not storing the full history of those events over time. They're updating their state and then throwing out some of the old events that help to populate that state while ensuring the state is maintained by each node in the network. Storage in Hedera is relayed to something called the Hedera mirror network, or more specifically, mirror nodes. So these nodes operated either by third parties like Kabuto or Dragonglass, or by application providers themselves like AdStacks, are receiving the full history of events from the Hedera mainnet, every message and its associated consensus timestamp. They'll either store these messages for all time if they're providing a mirror node as a service, or it will only store the messages relevant to their specific application. Now, the final component is the actual Hedera Consensus Service itself. So a Hedera account would submit a message to the Hedera Consensus Service. It would include a message, which is the thing custom to that application, whether it's a specific set of instructions, a Fabric transaction, or something else. It will specify a topic ID, which is the unique identifier used to associate messages from that application or network with one another. And it would need a submitting account, which is the Hedera account that pays the 1/100th of a penny transaction fee for a message to come to consensus. Now, in return, the Hedera mainnet would come to consensus and provide the consensus timestamp, the sequence number, and the running hash for that message back to the application, or in this case, to the Fabric network. And you'll see how that can be then used to construct a private Fabric blockchain. I'm going to also quickly give you a quick refresher on some of the components of Hyperledger Fabric that we'll mention in this webinar. The Fabric network refers to the network of participants who have built a distributed application for something like supply chain, or for identity management, or for financial markets. And it refers to the actual blockchain that is shared between those participants for the purposes of that use case. The peer refers to an individual organization's database or copy of the ledger, and it's what they store in their on-premise or cloud environment. The IBM Blockchain Platform supports multiple cloud environments for this peer. The orderer is the entity which an organization would host to relay a transaction to and from the Hedera mainnet. The certificate authority is how certificates and access are managed within the private network from a cryptographic perspective. The chain code is the Fabric programming model for smart contracts to ensure that each member of the Fabric network executes the same business logic in order to support their use case. And finally, a channel is a mechanism of establishing a subledger within a given Fabric network, either for a specific purpose in the network, like administrative communications versus applications, or to enable communications between a subset of the participants in that network. And you'll see each of these exposed through the IBM Blockchain Platform user interface that Zin has stood up for his demo. So now that we've got a bit of the primitives on both the Hedera and the Fabric side, I'll give a brief overview of what happens with the use of the Hedera Consensus Service plugin. First is a transaction would be proposed by the Fabric peer. This would collect signatures from the other members of the network in compliance with the policy determined by the Fabric network. The client application would then broadcast that endorsed transaction to their organization's orderer. We'd suggest one orderer per organization to support greater decentralization. The orderer would then use that Hedera Consensus Service plugin to fragment and submit the transaction as a Hedera Consensus Service message to the Hedera, in this case, public testnet. Fragmentation can be used if the Fabric transaction is greater than the 6 kilobyte limit on a Hyperledger or on a Hedera Consensus Service message. And the plugin supports both the fragmentation and reassembly of those messages. The Fabric orderer would submit it with the topic ID that's configured for that Fabric network. And the message would then come to consensus by the Hedera mainnet nodes. Once it reaches consensus, that would be streamed out to one of a multitude of mirror nodes. In this webinar, you'll see the Kabuto mirror node watching the transactions in real time and relaying them to the Fabric network. The plugin would then allow each member of the Fabric network's orderer to subscribe to that topic ID and be notified in a matter of seconds when that message has reached consensus, so that they can then use that message in consensus order provided by the Hedera mainnet to order transactions which update their private blockchain. So they would essentially each individually receive the consensus order of transactions from the Hedera mainnet and use that order to update the blockchain stored on each of the peers in the network. You'll see a few components in practice here that we've built into the orderer, such as the ability to handle transactions, submission to the Hedera mainnet. We include the channel management in specifying which topic ID is used, as well as some of the other Fabric components that Zin will talk through. One thing I'll mention as well is one of the capabilities we've built with the plugin is pluggable or optional encryption. So Hedera Consensus Service messages can either be the plain text of the Fabric transaction or can be fully encrypted so that only the members of the Fabric network can interpret what the message is meant to say. And in doing so, helping to suit a broad base of both public and private use cases. So with that, I'll pass it to Zin, who's going to jump into using the IBM Blockchain Platform and our plugin.
Hey, everyone, this is Shindy from Swap. As Andrew introduced, I am a senior software developer, and I work primarily on Hyperledger Fabric and HCS integration. All right, it's great to meet you all here virtually, and let's dive into the demo directly. I'm going to share my desktop. Just hold on a while. All right, so this is a summary for the topology and the steps of the demo I'm going to run today. So for the topology, we will have two organizations. One is for the ordering service, which has a single HCS-based orderer. And we also have a business organization with a single peer node. We have a business channel, it's Fabric channel, it's called app channel in this demo. We are going to show the Fab Cloud chain code. It's actually from the Fabric samples official repo on the Hyperledger. And we are also going to demo a sample JavaScript client. It's from the Fabric samples repo. And for the components, including the peer node, the CAs for the two organizations, and the MSP definitions. These are managed by IBM Blockchain Platform service. And for the orderer node and the channels, I'm going to create them in the IBM Cloud Virtual Server. All right, this is the this is a landing page of the IBM Blockchain Platform service. It's a offering by IBM Cloud. So in order for you to create one like this, you need a IBM Cloud account. And also because the IBP service runs on the Kubernetes cluster, you have to create a Kubernetes service and deploy the IBP service on it. Because some of the steps actually takes quite some time to initialize, for example, the Kubernetes cluster creation and the IBP service creation, the CA creation and the corresponding identities, registration, enrollment. So for these 3 steps, I've done them before the event. Literally, these are the 2 operations the CAs are created, and these are the required identities. I have pre-registered. This is for the order organization, as well as the MSP definitions for the 2 organizations, as I mentioned before. And with all those prepared, I'm going to continue on step 4, which is to create the peer node on the organization 1. I'll name it peer 1. And since this is a peer in the business organization, the CA should be org1. And I'll use a pre-created identity that's called peer1 for this. The MSP will be org1 MSP. And for the admin, I'll choose a pre-created org1 MSP admin identity. And that's all the fields we have to fill in for the peer node. And by the way, there is a detailed official tutorial, step by step, and all the details for how to use the IBP service to create a network. I'll share the links after the webinar. I'll send emails to you guys. And the peer creation takes a couple of minutes, so we can parallelly run other steps. And so now we are at step 5. I'm going to bring up the order node. And actually, before bringing up the order node, we have to do some configuration tasks, which includes we want to create 2 HCS topics. One is for the Fabric system channel and one for the app channel. And also we want to update the config.txt YAML file, that's a configuration file, to create the channel artifacts. So once that's done, we can use the config.txt gen tool from the Hyperledger Fabric project to create the Genesis block for the system channel, as well as a channel creation transaction for the app channel. These steps will be taken care of by the prepare script. All right, looks good so far. And next, I'm going to bring up the order Docker container. I'll check the log of the order node. And this is the HCS topic ID used for the system channel. And when I'm running the demo, I want to use, as Donna mentioned, we will use the Caboodle Explorer to monitor the HCS messages in real time. Okay, all look good. And there is an initial message sent from the order to the HCS service. And for all the remaining steps, most of them, it's going to be command line, and I'm going to issue the commands in a CLR container. As I mentioned before, the peer nodes takes some time to create, and actually the following steps will be blocked on this. And I think we can take some questions.
Sure. So I can just mention one that was answered in the chat here. A user was asking whether proof of work or proof of stake was being used for consensus. And I clarified that the Hedera mainnet uses the Hashgraph consensus algorithm, which is a fully decentralized and performant consensus algorithm. And this is exposed directly through the Hedera Consensus Service. So any Fabric network would get access to this consensus algorithm operated on the mainnet through a simple set of APIs and through the interfaces and is shown here. I see our peers up and running, so I'll turn it back over to you.
Yeah, it's up and running because there is a green block on the top right corner. All right, so next steps is that I'm going to create the app channel. And because Fabric is a permissioned network, we have to get the required signatures of the channel creation transaction. Otherwise, even though I try to send the channel creation to the order node, it's going to be rejected. All right, so it's signed, and I will use the peer command line utility to send the channel creation transaction over to the orderer. And in the meantime, you can look at the Kabula Explorer. Yep. So the channel is created on the order, and we can see a couple of about 6 new messages just popped up. In order to form the organization on the new channel, we have to issue another command to have peer 1 node we just created in IBP service to join the channel. Cool. So once the peer nodes joins the channel, we will see some change here. Yep. So on the view of the peer node, we will see there is 1 channel the peer has joined so far. That's the app channel we just created. And once we click the app channel, we will see the blockchain. There is 1 block right now. That's the Genesis block for this particular channel. And in this block, there is no business transaction because this is a configuration transaction. And next, we are going to deploy the FABCA chain code onto the channel and run a couple of transactions on it. And so the chain code has a life cycle. To deploy the chain code on the channel, it involves usually 3 steps. The first is that we want to install the FABCA channel to peer 1 node. And we want to verify. Yep, all look good. The FABCA chain code is already installed onto peer 1 node. And next, we want to instantiate the FABCA chain code onto the app channel. Depending on the particular chain code, this step is going to take somewhere from 1.5 minutes to up to a couple, maybe up to 5 minutes, because what's happening under the hood is the chain code in this example, it's written in JavaScript and it's based on Node.js. There is a container in the peer node which is going to download all the dependencies and compile it and provision it.
Maybe while that's going on in the background, I'll mention a few of the other questions as well. And then Zin, you can stop me when we're ready to jump back into the demo.
Sure.
There was a question about how consensus nodes relay transactions to mirror nodes. So currently the mirror node is in beta and will soon be publicly accessible in beta, but it uses a method of essentially pulling transaction records from a distributed set of S3 buckets to store those records for longer periods of time. As we move from beta into the full mirror node, that will change so that the mirror node can participate in Gossip as well, but that's what's currently used today. There was also a question asking about the current use of the certificate authority. So what we did for this demo was created the Hedera accounts, which are used by the Fabric network out of band using a separate CLI tool. But long-term, I think our goal, with the Fabric community would be to support the CA, creating and managing accounts. And given it shouldn't be, much more different than typical key management, that's something I think we'd be excited to pursue. And then finally, I think there was a question about the 7 messages. What you see is one Fabric transaction would be fragmented if it's sufficiently large into a series of messages, which the plugin helps to both fragment and then reassemble in consensus order.
All right, so the chain code is successfully instantiated and also ran a command to confirm that. And I think at this point, I'm going to switch to the application channel. And because two reasons. First, we will no longer send any transactions to the system channel because we have no more channel configuration update or new channel creation. And the second, once we deploy the cloud chain code, we will see business transactions on the business channel. So it should be, yep, as I just mentioned, there are already a couple of transactions. And so commonly for the chain code in Fabric, there should be a initialization function, which is used to populate the initial data. There's no difference for the Fabcard chain code. So I'm going to invoke the init call of the chain code. And the name of the function is actually defined by the chain code itself. And for this particular Fabcard channel, the args for the init call is actually empty. And what happens is this particular chain code populates a list of key value data with the car name and the value, the car name as the key, and the value includes a couple of attributes like the make, the model, the owner of the car. And we can actually use the IBP web GUI to inspect the data. Yeah, all right, it's here. And the input of this business logic, business transaction is the init call, and the output is a couple of key value data for the cars written into the ledger. Okay, I think with all this, we are at the last step. I'm going to show you the sample JavaScript client. So typically for a Fabric application, there will be a special account with the privilege to onboard and register, enroll other normal users. And for this example, for this demo, I pre-created an account called app admin that has the attribute href.registrar.rows, and the value is star, which means this particular account has the ability to create other accounts. So for the application, so we need the credentials of this particular account, and the first step we will do is enroll the app admin. What it does is actually downloads the credentials, the keys of the app admin account. And after that, we are going to use the app admin credentials to create a normal user. And from this step on, we will be using the normal user to do queries or creation updates of the record to the ledger on. So this is a read-only transaction. Excuse me, this is a transaction to add a new entry into the ledger with the key, I think it's car 12. And after that, we can do a query. Yep, the data is written. We can also look at the block history from the IBP web GUI. There is a new block created with a single business transaction. And the data is exactly as what we just saw here. Yep. All right, I think that's all for the demo.
Fantastic. So I'll just mention a few things. You can see at the right here, again, we've got one of our GitHub repos up. So the plugin and its samples can be accessed either in our Hashgraph GitHub at docs.hedera.com or within the Hyperledger GitHub under our Hyperledger lab for pluggable Hedera Consensus Service. And so we're really hoping to jump into supporting as many users as we can on this one. So don't hesitate to reach out or let us know if you're working on a project with Fabric that might be well supported through the use of the Hedera Consensus Service. I see there's another question here about if there's one topic per orderer or one topic per channel. First I'll say it's customizable, so you can configure topics both for however many you need in the network and with only access or write ability by specific participants. In the context of this demo, we built one topic per channel so that each of the Fabric organizations can independently get the updates from the topic or for the channel they're listening for or a part of. But that's something that's configurable as well. So I think that wraps it up unless there's any other.
Yeah, I do have some questions that was sent to me directly through the DMs. One came in, is this officially part of the Hyperledger Foundation?
Yeah, so Hyperledger is for those who aren't familiar, is an open source project under the Linux Foundation. Hyperledger has underneath it a set of different projects that support the use of distributed ledgers in enterprise use cases. Hyperledger Fabric is one of kind of the main, most adopted permission frameworks for building a distributed ledger network. Now, the plugin itself was just recently approved as something called a Hyperledger Lab, which means that it now fits within that governance structure and can be aligned to the roadmaps of Hyperledger as an organization and Hyperledger Fabric. So right now it's out there in lab form, and if you'd love to participate, contribute to it, our goal next is to really start to foster some community adoption within our community here and within Hyperledger as well. So we're eager to continue to drive its adoption and growth through that forum.
There are two more questions, Donna. Yep.
Yep.
More coming in. Yes.
One of the questions was if we're planning to extend broadcast before endorsement. This is something we've been looking at, essentially allowing the peers to communicate directly with HCS. So I think that's one of the kind of key criteria we're going to hopefully validate in the community and get some feedback from users on before fully building out, but that is something we're exploring. I see a question here about starting development using Hedera and which programming languages. So on our docs page, we have a number of kind of getting started tutorials, including both using Hedera itself and also using this plugin that you saw Zin use here. We have SDKs available today in Go, Node.js, Java, and a number of other community supported SDKs as well. So all of those can be found at our in our Hashgraph GitHub repo. I think somebody was asking about particular projects. Certainly, feel free to reach out to myself, Donald@hedera.com, and we can carry on that conversation of how to support your projects. Somebody asked about how to talk with clients about using Hyperledger Fabric. So what I would suggest, especially when selling Fabric with HCS, the real benefit of Fabric plus something like the IBM Blockchain Platform is you get the core components of tooling, identity management, smart contract management, ledger management, and the ability to deploy those components to enterprise infrastructure. So whether it's in IBM Cloud, Microsoft Azure, AWS, Fabric is supported in a number of those different cloud environments. So it's really a good framework for developers who are building those types of enterprise network use cases. There are other frameworks out there. R3's Corda is particularly well adopted in financial services and has some great privacy features as well. So there's a multitude of different options available there. There was a question about if there's a plugin for Hyperledger Indy. Not currently. That's not necessarily because we're opposed to it. We'd actually love to kind of explore and hear, what the community interest is on that plugin. So we'd definitely be interested in exploring those plugins if there's a community request. I think there was another question about Raft configuration parameters. I'll leave that to Zin as well.
Sure. So for the Raft configuration, about the Raft configuration parameters were populated. Do you use any of them? No. So the config.txt.yaml file has configuration parameters for different types of consensus service, which are actually used in runtime. Really depends on the type of consensus service we choose in that YAML file. So in case of HCS orders, we don't use any of those special Raft configuration parameters.
I did get another question directly about what are the benefits of using Raft versus Hedera Consensus Service?
Yeah, so I would really focus it on 3 components. One, it's ease of use. So instead of needing to configure, deploy, and manage your own Raft cluster, you can get decentralized consensus as a service available through a simple set of APIs. Second is HCS uses the Hashgraph consensus algorithm, which is the only asynchronous Byzantine fault-tolerant consensus algorithm pretty much in the market, which means you have fully distributed consensus. Every node participates in every round of consensus with high performance in both the throughput and in terms of low finality. And then finally, again, it's also not something that has to be governed as well. So you get access to the Hedera mainnet that's governed by our distributed council, providing that consensus engine. Any other questions you have, Andrew?
Nothing. Looks like there's a couple more in the Q&A, but nothing in the DMs.
Great. I think we'll definitely share some of these links as well in the follow-up email along with these slides. Love the idea of doing a Corda session as well. I think we've got another webinar even tomorrow talking about the use of HCS. I'll give a special shout out. I see 2 former colleagues, Brian Gross, who helped us from IBM with the initial architecture around the HCS plugin, and Sam Winslet, who built the beautiful IBM Blockchain Platform UI that you saw Zin using. So good to see you guys checking out our status as well. But unless there's anything else, thanks everybody for the time.